All right, hello. Today we are doing 10-1 right angle trig. And bear with me because this is our first distance learning video. We are going to focus on finding the 6 trig ratios of a right triangle and determine the side lengths using trig relationships. A lot of this is what you learned in geometry, so this should be reviews. I'm going to try to go over some of this quickly with you. So remember SOHCAHTOA. The SO stands for the sine function. The sine function is going to be the opposite over the hypotenuse. And the hypotenuse you can always find because in the right triangle, it's going to be across from the right angle. So the hypotenuse is always across from the right angle. The angle that we are going to use is theta. So theta is a Greek symbol that is commonly used to represent an angle. So from this angle, the opposite side is not touching the angle. If you look, the hypotenuse and the adjacent both touch the angle. They make the angle with the sides. And the adjacent, remember adjacent means next to. So it is the side next to the angle that is not the hypotenuse. All right, the cosine, which is pronounced cosine like this, okay, is the adjacent over the hypotenuse, and that makes the ca, right? So cosine is adjacent over hypotenuse. So don't call it cos, it's cosine, not sin, but sine. But the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent is going to be the opposite over the adjacent. Okay, that's the TOA. And then I got a nice little joke in there for you from your book. What do you call a man at the beach? A tangent. I thought that was pretty good. Adjacent, and this is adjacent over hypotenuse. Okay, so here are your trig functions. Remember that all of these are ratios, and a ratio is a fraction. So you are comparing these two side lengths. So this is the ratio of the length of the opposite leg to the hypotenuse. This is the ratio of the adjacent leg to the hypotenuse. And this is the ratio of the opposite leg to the adjacent. Okay, adjacent to hypotenuse and opposite to hypotenuse. Okay, and then this does give you an example, and this is what we just talked about up here. We are going to go right into example 1, which says to find the values of sine, cosine, and tangent functions for theta. Leave your answer as a fraction in simplest form. So that means if you can reduce the fraction, you are going to do so. All right, so here's my theta. The first thing I do is I label the hypotenuse. So across from the right angle is 25. Because this is theta, this is the adjacent side, and this is the opposite side. When we go to part B, we can see theta's at the top. So now the opposite would be here, what we think of as the base, and then the adjacent would be here. Again, hypotenuse is always across from your right angle. Okay, so whenever you're writing these out, notice here the sine, the cosine, the tangent, they're of theta. So you have to make sure that you put theta in there. So the sine of theta is the opposite over the hypotenuse, your O over H, so this would be 7 over 25. Okay, you can't have the sine of nothing. It's always going to be of an angle measure. Okay, so that's your O over H. Your cosine is the adjacent over the hypotenuse. So the adjacent is 24 over 25. And then your tangent is O over A, so 7 over 24. Okay. All right, so now we're going to do part B, which is very similar, but when we do the sine, right, the sine of theta, if I do O over H is 6 over 10, but then that reduces. 2 goes into both, so divide by 2, you get 3. Divide by 2, you get 5. So we'd say the sine of theta is 3/5. Okay. For the cosine, you're doing the adjacent over the hypotenuse. So for the cosine, if you do adjacent, which is 8 over the hypotenuse 10, that reduces to 4/5. Again, divide by 2, divide by 2. So your cosine of theta is 4/5. And for your tangent, you have O over A, which is 6 over 8. 2 goes into both of those, so that would be 3/4. All right, moving on. There are reciprocal trig functions. So aside from the cosine, the sine, and the tangent, we have the cosecant, the secant, and the cotangent. Okay, so cotangent is usually the simplest to remember because it has the word tangent in it. And then, do you remember what the definition of a reciprocal? What's that? You want me to tell you? Reciprocal, the definition is when you multiply a value by its reciprocal, you get 1. A lot of times we think of it as 1 over the function. So the secant is the reciprocal of cosine. The cosecant is the reciprocal of sine. So the way that I remember that is if it starts with a C, the reciprocal has to start with an S. So cosecant and sine, secant and cosine. Okay, so it's like opposite there. And like I said, cotangent has tangent right in the function. So that one is usually simplest to remember. Okay, so before we had SOHCAHTOA, right? So we had the O over H. Now instead of O over H, we have H over O. Instead of A over H, it's H over A. And then instead of O over A, we have A over O. So I say ho, ha, A-O. And that's how you can remember that. Even though you probably won't. You are just going to flip the fraction. Okay, so if before it was over A, you are just going to flip all those because they are fractions. You can also look here. So the cosecant is 1 over the sine. Secant is 1 over the cosine. Cotangent is 1 over the tangent. And what ends up happening is those are going to flip. Which really, if you think about this, if you have 1 over the sine, and sine is O over H, if you were to divide these, right, it would be like you're multiplying by the reciprocal. 1 divided by a fraction would be like 1 times the reciprocal here. 1 times anything is itself. And we have H over O. Okay, so just a little bit of reasoning on how those are similar. All right, now we are going to be using the Pythagorean theorem. So the Pythagorean theorem, remember, in a right triangle, if you have a squared plus b squared, we know that's going to equal c squared, and that's where a and b are the legs, and then c has to be the hypotenuse. And I apologize if that was all over the place, and I hope I'm not giving you a headache with this thing. So I asked you to draw a picture representing the Pythagorean theorem and to just label the sides of the triangle ABC. So I just wanted to make sure that you guys understand that it is in a right triangle, so we'd want to put our right angle here, and it doesn't matter if you have A and B labeled this way, or you could also have A here and B here. It's just C has to be across from the right angle. Okay. All right, and then we'd know that a squared plus b squared equals c squared. In our second example, we are going to find the values of all 6 trig functions for theta. And then again, you do want to make sure that these are in simplest form. So we're only given 2 sides. We can find the third using the Pythagorean theorem, which is what we're going to do. So it's the hypotenuse that we need to find. So we can think of this side as C as the missing side. So we have 70 squared plus 24 squared equals C squared. You can use your calculator to do this calculation since it is a little bit larger, and then we'll take the square root of both sides, and we will get a nice even number here. It will not always be even, so you do want to keep it in simplest radical form if you don't get a whole number. Okay, so now we know that this is 74. So again, we're going to look at theta, and we're going to label from theta. Hypotenuse is the same no matter where theta is, but this is opposite of theta, and this would be adjacent to theta. So now we're going to find the 6 trig ratios. So for the sine would be O over H. So 70 over 74. So if I have 70 over 74, I know 2 goes into both of those, so I'm going to reduce by 2. You cut it in half, so it'd be 35 over 37. Okay, and that's going to be your sine of theta. Okay, the cosine of theta, we know that H is on the bottom. A is going to be 24. Again, you can cut them in half. So if you divide by 2, you'll get 12 over 37. And that is the least you can reduce to. When you're making your thetas also, you can see like I usually make mine all together. You don't have to do it just like that. This is 70 over 24 because I have O over A. Divide by 2. I get 35 over 12. And that is my tangent of theta. Okay, and then from there you can do your cosecant, secant, and cotangent. Again, make sure you're putting your thetas in here. Really, I should have given myself more room, but I didn't, so I'll put them here. So we know that the reciprocal for sine is going to be the cosecant. That abbreviation is CSC, so the cosecant of theta is just going to be the reciprocal. So you're just going to flip the fraction, and of course we want to use the reduced form. For cosine, the reciprocal is secant, and that's SEC. And then your theta, here's another way you can make theta. You can do a 0 with a line through it. That's another way you'll see it. And this will be 37 over 12 when I flip. And then you have the cotangent. And sometimes you might see theta like that, but it really looks like the null set. So I like to do a little loop-de-loo. I don't like the way I wrote that. Okay, so cotangent of theta is going to be 12 over 35. All right, and we're going to do the same thing for part B. Notice that part B does have a radical in it, and I think you were not supposed to be given this side, so whoops, we're going to pretend it's not there. And I don't think you can see it anyway right now, but I will take that off of yours so then you won't see it. Okay, good times. All right, so again, we're going to solve for the missing side. I'm just going to call this B. So I have 3 squared plus B squared equals 3 root 10 squared. Oh no, I have to square and there's a square root. What do I do? Well, you just have to square the 3, which is 9. And then think about what happens. These are inverses, right? So when you have the square root and you square it, you'll just get 10. So it'll be 90. You can even check that with your calculator. So 9 plus b squared equals 90. Subtract 9 from both sides. So b squared would be 81. Okay, so I minus 9. And then to get b by itself, you take the square root. You don't have to worry about the plus or minus here because it is an actual side length. So we can reject the negative answer, and this side will be 9. All right, and then our theta is here. This should have the right angle in it. We just have to put that in. So hypotenuse, and that will be given to you in the book, just FYI, or on your worksheet. Okay, so now we are ready to find the trig ratios. All right, so we're going to do the sine of theta. Ooh. Sorry, I have this on a tripod and it was going down. We're saying timber. All right, so sine of theta, O over A would be 3 over 3 root 10. Okay, but here, those are going to reduce, right? 3 over 3, so I'd have 1 over square root of 10. But what can't we do? We don't want to leave this square root on the bottom, so we would rationalize, okay? So then the sine of theta would be square root of 10 over 10. 1 times root 10 is root 10. Root 10 times root 10 is 10. All right, and now I'm going to do the reciprocal. So I would do the cosecant. Now, if I do the cosecant and I just flip this, I'm going to have to reduce again, okay? So instead, just reduce this one here. So if you had 3 over 3 root 10, the cosecant would be 3 root 10 over 3, right? Where these would just cancel. So then you would have the square root of 10. And that is going to be your cosecant. And then you don't have to reduce a bunch of times. Okay, so now we're going to do the cosine. So your cosine of theta is A over H. So you have 9 over 3 root 10. Again, you can reduce this part. So 3 goes into 9 3 times. It goes into itself once. And then you're going to multiply to rationalize. So your cosine of theta is going to be 3 root 10 over 10. And then to do the reciprocal, the secant, we're just going to flip this one over, okay? Or really, you could just flip the reduced one over. So if you had 3 over root 10 before you rationalize, this is just going to be root 10 over 3. Okay. And the last one is the tangent. So for your tangent, you have O over A. So you have 3 over 9, which we know is going to reduce to 1/3. And the reciprocal of 1/3 is 3. So that will be your cotangent. Yay! Okay, so you are going to have some radicals that you'll have to deal with in there. All right, moving on. Last page is going to be solving with trig functions. And you can see that we put this diagram in here. This is all of your special right triangles from geometry. So you had the 30, 60, 90 triangle, and you had the 45, 45, 90. So I know it's been a while since you've looked at those. But when you did this last year, you talked about the special rules, like how the hypotenuse is twice as big as the short leg, and how the long leg is the square root of 3 times the short leg. And remember to find the short leg. It's across from the 30-degree angle. The long leg was across from the 60-degree angle. So based on this special right triangle, you can find the sine of 30 degrees by doing the opposite over the hypotenuse. So this is like the opposite over the hypotenuse. The sine of 30 is 1/2. That is going to be something eventually that you're going to come to know. The sine of 60, if I did the opposite over the hypotenuse, would be root 3 over 2. And then you can look at your cosine of 30, your cosine of 60. If you look here, you can see that the sine and the cosine, when I've switched the angles to the other acute angle in the triangle, these are going to be flipped as well. And then your tangent, you'd have 1 over root 3, so then you would rationalize to get root 3 over 3. Tangent of 60 is going to be square root of 3, so you can use those. And then for the 45, 45, 90, whatever the side length was, the hypotenuse was the square root of 2 multiplied by that side length, which means if you were to find the sine of 45, the opposite over hypotenuse, it would reduce to root 2 over 2. The cosine would be root 2 over 2. And the tangent, 1 divided by 1, would be 1. Okay, so you can use those if you have a special right triangle. All right, now with the diagrams, we're going to have to draw some stuff in that is going to be given to you. So this is a right triangle, and you know that this angle is 30 degrees, and you are trying to find x, which x is right here, and then you are given that this is 74. We're just going to fill these in for the rest of them too real quick. So this is a right angle. We know that this is 45. This is 20. And here is our x. And for C, this is a right angle. This is 6. This is x. And we know that this is 20 degrees. Okay, so if I'm trying to find x, what I want to do is I want to label my opposite and my hypotenuse and my adjacent from my given angle. Okay, so the given angle is the 30 degrees. So I would say x is my opposite. This is across from the hypotenuse. So this is, the hypotenuse is across from the right angle. So this is my hypotenuse. So I have O and H. So what I want to do is set up the trig function. So the first thing I do is I label the sides. So I label sides with O, A, and H. Really the two sides I label are the given side, so the number side, and then the unknown. And then I'm going to pick which trig function matches. So if it's O and H, using SOHCAHTOA, okay, I'm going to pick sine. So I know that the sine of my angle is O over H, so that's why I'm choosing it for this one. And then you're going to set up your equation. And then after we do that, we are going to solve. And if you are using your calculator, make sure your mode is in degrees. Okay, so the sine of, and I'm actually going to plug in my angle. So my angle is 30. So the sine of 30 degrees equals x over 74. So if I'm going to solve this for x, I'd want to multiply both sides by 74 to move them out of the way. And you can either use your calculator for this, or based on what we talked about above, if you have the sine of 30, the sine of 30 is 1/2. So if you do 74 times 1/2, or if you do the sine of 30 in your calculator, you'll see that you will get your final answer as 37. Okay, so really, you can do either one. You can use your special triangle or you can use your calculator. All right, and for the next one, we'll follow a similar process. So here is the hypotenuse. This is next to the 45, so that's my adjacent. So it's A and H, so I'm going to set up the cosine. So the cosine of 40 degrees is A over H. So in this case, it's going to be x over 20. To solve for x, I'd multiply both sides by 20. Okay, and if you did use the cosine of 45 as root 2 over 2, you would have an exact answer. So think of this as like 20 over 1, right? If you have 20 root 2 over 2, you can reduce because those are both on the outside. So this would be 10 square root of 2. That would be your exact answer. And then if you used your calculator, you would get approximately 14.1. This doesn't have the units on it, so we're just going to leave it like that. Okay, and again, your calculator does need to be in degree mode. So make sure when you go to mode, it is set to degree, and then you can I'm going to type in the 20 cosine. Here's your cosine. Now you hit tangent of 45, enter, and then you can see your 14.1. Okay. All right, and then our last one, we have the angle 20, so this is O and this is A. Okay, the H does not have anything there. So we have the number, we have the unknown, so this is going to be the tangent of 20 equals O over A. So now X is on the bottom. You can think of this in a couple of different ways, okay? So if you wanted to solve, do not multiply by 6. You'd have to multiply both sides by X first to get X from the denominator. So I'd have X times the tangent of 20 equals 6. To get X by itself, I would divide both sides by the tangent of 20 degrees. And I'm not sure if you remember this from last year, but really you'll start to see the pattern is whenever you have the unknown on the bottom, the variable on the bottom, what happens is these two like flip-flop places. So it's the X and the tangent of 20 that flip. Now notice that 20 is not one of the angles in our special triangle, so you do have to use your calculator to do this, and you will get approximately 16.5. Okay. All right, the next two are story problems, and you will have to set up your triangle for these. So in a water skiing competition, a jump ramp is 19 feet long from the water to the top of the ramp. If the angle between the ramp and the water is 15.1 degrees, what is the height to the nearest foot above the water that the skier leaves the ramp? So I always try to draw like my right triangle first, and it honestly doesn't matter what way it's going, but they say that the ramp is 19 feet long. So the ramp part is what you're actually going up. So this part is the 19 feet. Okay, and then the angle between the ramp and the water. So it's a water skiing competition. This is where your water is. So this is the angle between the ramp and the water, and that is 15.1. And remember that your height is always going to be with the right angle. Okay, so the height is here. This you might hear that referred to as horizontal distance. Okay, so again, we're going to label using our angle. So this is across from the hypotenuse, so it's from the right angle, so it's the hypotenuse. This is the opposite. So I know now that I want to use the sine. So this is the sine of 15.1 degrees, and that is equal to the opposite over the hypotenuse. So to solve, I'm just going to multiply 19 times the sine of 15.1 degrees in my calculator. Okay, so 19, I'm sorry, I know you can't see that well. 15.1, okay? So just like that. All right, so you get 4.9, but then remember it says that you're rounding to the nearest foot, which is the nearest whole number. So this is going to be about 5 feet as the height. Okay, and then the last one. You have a biologist whose eye level is 6 feet above the ground, and it measures the angle of elevation. So I'm not sure if you remember from geometry, but the angle of elevation means you start at a horizontal and then you move up. There's also the angle of depression, and the angle of depression would be you start at the horizontal and you go down. Now, the angle of elevation is going to be to the top of a tree. So the biologist with her pretty blue eyes there, her pretty pink eyes here, that's at 6 feet, okay? So her eye level is the 6 feet above the ground. The angle of elevation to the top of the tree is 38.7 degrees. And then the biologist is standing 180 feet from the tree's base. So this is the 180 feet. You have to find the height of the tree. Just this beautiful thing. Okay, to the nearest foot. Really, this is like the top of the tree, sorry. This is a very large bird in the tree. Caw-caw, caw-caw. It's a drone now. Okay. Okay, so you're trying to find the height of the tree. So the height of the tree would be this. So this is a two-step process. So first we have to find this value, and then we're going to have to add that to the eye level height for the top of the tree. All right, good times. So again, we're going to take this. We know this is the opposite side. This is the adjacent. So we're going to do the tangent of 38.7 degrees is the opposite over the adjacent. So we're going to multiply because the variable's on the top. And you will get approximately 144 feet. And then we just have to add the 6 feet from eye level. So the height of the tree to the nearest foot would be 150. All right, your assignment is on your slide, and you can check your answers and then submit that. Okay, have a lovely day. Bye.